Hello students, so welcome to my next online class, and this is the continuation video of my previous chapter which already I started, that is work and energy. So in an work and energy in this chapter, few topics we have already discussed. Okay, so let's revise those topics and then I will start our new topics today. So the first topic which we have learned in my previous class, that was work. So first question arises, when a work is said to be done? A work is said to be done when a force is applied on an object and that object moves with a certain distance. So if an object is moving in a certain distance, then we say that work is done. Otherwise, if that object is not moving, then we say that no work is being done. For example, when we push this wall, if this wall is not moving, there is no displacement, then we say that we have applied no work. Similarly, if you are sitting in your bench and you are reading your book whole day, then also you will be considered as doing no work because there is no any physical movement. Okay, so though you have mental pressure, that won't be counted as work done. Okay, so what is the SI unit of work is joule. Okay, so SI unit of work is calculated in terms of joule. Now you see how this work and energy, they are related with each other. This work and energy, they are directly related to each other. That means if you don't have any energy, then you cannot do any work. Or a boy is having more energy, then he can run across a field 10 times. But a boy, we don't have any energy, he can just run 3 times. So we say that the boy having more energy can do more work, that is 10 times he can run across the field, but whereas the boy having low energy can only run 4 or 5 times. So this how we define energy. So that means energy can be defined as capacity or ability of a body to do work. Okay, so if you have more capacity of doing work, then we say that you have more energy. Or if you have less capacity, then you have less energy. So capacity of doing work is energy. That means work and energy are related to each other, so their SI units also remains same. That's it. That is SI unit. SI unit is joule. Okay, JOULE, that is denoted by capital J. So many students, they make the spelling mistake here, joule spelling. So make sure you write correct font. Next, mechanical energy, the total summation of kinetic energy and potential energy is termed as mechanical energy, that sum of these two energies. Okay, so when these two energies, when they combine, then only we consider to be as mechanical energy. So mechanical energy is divided into KE and PE. That means KE stands for kinetic energy and PE stands for potential energy. So kinetic energy, how we are going to define here? Kinetic energy means the energy possessed by a body which is in a state of motion is called kinetic energy. The energy possessed by a body when by virtue of its motion or when it is in a state of motion is called kinetic energy. So when an object is in motion, the energy contained in that object is said to be as kinetic energy. But whereas when an object is not in motion, okay, so we say that energy stored in that body is in terms of potential energy. So potential energy is divided into again two types, that is GPE and EPE. GPE stands for gravitational potential energy and EPE stands for elastic potential energy. So potential energy are of also two types, one is gravitational potential energy and one is elastic potential energy. Gravitational potential energy means here, suppose you have pulled a bucket of water from a ground floor and you have taken to a top floor of your building and you have kept there. So you have done work against the force of gravity. Okay, so while carrying that bucket of water, you have applied your force against the force of gravity. Gravity is pulling that object, that bucket of water, but you have carried that bucket of water to a top floor. So the expense of that work done is being stored in form of potential energy. So when you carried that water and placed in your top floor of your home, that means that work done is converted into potential energy. Now what energy that bucket is having, that bucket containing water, that is potential energy. So the energy possessed by a body by virtue of its position or height is known as gravitational potential energy. Okay, Whereas what is EPE? EPE stands for elastic potential energy, means the energy possessed by a rubber band on stretching. That means when you stretch a rubber band, okay, so there is a displacement and you are applying their force against the force of restoring force. That means the rubber was trying to close, but you have done work in stretching that rubber, so you have done opposite work. Okay, so you have applied opposite force. That means that opposite force is being converted into elastic potential energy. So you will see the definitions from your textbook nicely, and you need to remember this one, GPE and EPE, that means gravitational potential energy and elastic potential energy. Difference: what is the difference between kinetic energy and potential energy, and what are its SI unit? So all SI unit is here same, that is joule. Okay, Joule. Now you see, apart from this, we should know kinetic energy and gravitational potential energy. On what factors does this depend? So kinetic energy, as I have told, when an object is in motion, the energy possessed by that body is kinetic energy. So kinetic energy depends upon mass and volume. So this is the formula of kinetic energy. Kinetic energy equals to half mv square. That means it depends upon mass and it depends upon velocity. If an object is moving with high velocity, then we say that it has more kinetic energy. Whereas an object is having less velocity, so we consider it to be as less kinetic energy. That means kinetic energy depends upon velocity. How much? Square of that velocity. And also it depends upon mass. More the mass, more will be the kinetic energy. Okay, a truck and a vehicle, if they are moving with the same velocity, truck will have more kinetic energy because mass is more. Okay, similarly it depends upon velocity. If an object having more velocity will have more kinetic energy. So this was kinetic energy. Next you see potential energy, that is gravitational potential energy. Generally we say the gravitational potential energy, it depends upon mass, it depends upon acceleration due to gravity, and it depends upon height. That means mgh. Okay, so that means mass, acceleration due to gravity, and height. So more the mass, so more the bucket containing more water you are taking from ground load to top load, you require more force. That means you are doing more work. Okay, so that means it depends upon mass. And acceleration due to gravity means here gravity, where there is less gravity you need to do less work there, where you have more gravity you need to do more work there. That means it depends upon acceleration due to gravity also, and related with height. Okay, so more height you are taking that bucket of water, then more work you have to do and more energy is required for that. That is gravitational potential energy. So in simple words, kinetic energy depends upon how many factors? Two factors. One is mass and one is velocity. What is its expression? That is half mv square. Gravitational potential energy depends upon how many factors? It depends upon three factors. It depends upon mass, it depends upon acceleration due to gravity, and it depends into height. Okay, so these are the factors upon which these physical quantities depend. Now numerical will be based upon this formula. Like if I say a boy is riding a bicycle and the mass of that bicycle is, let us consider, 1500 gram. Okay, and whereas the velocity of that bicycle, let us consider 30 meter per second. Okay, calculates its kinetic energy. So this is the question. A boy is riding a bicycle whose mass is this much and velocity is this much, velocity of that bicycle, and kinetic energy, we have to calculate kinetic energy. So we know kinetic energy equals to half mv square. Half m is how much? 1500, but next to it is in gram, so we have to divide by 1000 to convert into kg. Okay, so 1500 by 1000 when you multiply, then it will become kg into v square, that means 30 into 30, right? So 3 zeros and 3 zeros cancel. So now we will calculate this one. 15 into 9 divided by 2. So 9 5 is 45, 4 135 by 2, 2 6 are 12, 2 7 are 14, that is 67.5 joule. So this is our answer. Okay, so this is how we calculate here. So calculation you will see once more here. So kinetic energy equals to half mv squared, the mass was m, we have converted in kg, and 30 into 30 because v square. Okay, so 30 and 30 got cancelled. So again we can cancel one more here, 2 15s, right? So will not get in point, the answer will be in one number only. So 15 into 3 into 15. So 15 15s are 225 into 3, 3 5s are 15, 3 2 are 6 7, 3 2 are 6, that means 675 joule here. So I have left out here 30. Okay, so when 30 will be there here 90, that means 2 6 are 12, 2 7 are 14, 2 5 are 10, that means here also 675 joule. Okay, so this is how we calculate. If we know mass, if we know velocity, then we will put in this formula. Okay, so easily we can calculate kinetic energy and gravitational potential energy. So the next topic we have conversion of kinetic energy and potential energy. Okay, so in kinetic energy and potential energy, so total energies remain same. Okay, so this is according to law of conservation of energy. So energy cannot be created nor be destroyed, it gets transferred from one form to another. That means when one energy is getting decreased, other energy gets increased. Okay, the total energy remains conserved. So same thing we see here, conversion of kinetic energy and potential energy in the simple pendulum. So this is a simple pendulum, that means it has one bob and it is tied with one string. Now when a bob moves, sometimes potential energy increases, sometimes kinetic energy increases. So how this conversion is taking place, I will explain this one. You see, let us consider initially, so this is the position, initial position of a bob connected with a string. So initial position, when it is at O position, potential energy was 0, and you see kinetic energy also 0 because it was at rest. Now but when I have pulled this ball to one side, now when I am leaving this one, it will move to and fro, that means one time forward, one time backward. On doing so, it has been seen that at point A and at point B, potential energy is maximum because height is maximum. Okay, so it's more displacement from the mean position, you can tell in this way also. So the maximum displacement from its rest position is at A and B, so potential energy is maximum. And we know kinetic energy depends upon velocity. So at point A and B, velocity was 0, so kinetic energy is 0. But at point O, velocity is maximum because when it is passing from this center, so velocity is increases. So therefore kinetic energy is maximum at O and potential energy is maximum at point A and B. Okay, so when it is moving left to right, first potential energy increases, then again it converts to kinetic energy, then this kinetic energy converts to potential energy. Likewise, potential to kinetic, kinetic to potential, again potential to kinetic, kinetic to potential. So like this conversion takes place, okay, between kinetic energy and potential energy. So apart from this, again we have one more example, like jugglers, those who are playing balls. Okay, so when they throw one ball, that ball goes in maximum height, that means potential energy is maximum in there, and when that ball comes down, that means potential energy converts to kinetic energy. So likewise, when they are playing the balls in air, so energy is converted from potential to kinetic and kinetic to potential. Same thing, one more example we have here, you see roller coaster. Suppose a block is at position A. So at position A, potential energy is maximum. Now when it is being pushed from this mountain on its way at this position of B, potential energy is converting to kinetic energy. So at point A, potential energy is maximum. At point B, potential energy is converting to kinetic energy. At point C, kinetic energy is maximum because speed is maximum at this here. Okay, so when it rises up, again kinetic energy converts to potential energy because of its height. So likewise, kinetic energy is converting to potential energy and potential is converting into kinetic energy. So likewise, the conversion of energy is taking place. So energy conversion is taking place in hydroelectric plant also. So hydroelectric plant means where the hydroelectricity is being produced, that is electricity is produced by water here. So here also you see that conversion of energy is taking place. Now question comes, what is the energy conversion in hydroelectric power plant? So you need to explain water stored in a dam is having a potential energy. So when water is stored in a dam, the energy possessed by that water is potential energy. When that water is flows through the gate of the dam, so that potential energy gets converted to kinetic energy. That means running water has a kinetic energy, and this running water, when it strikes with the turbine, that means there is a fan connected in the hydraulic power plant. There is a turbine. Okay, turbine is just a fan. When this running water strikes that blades of the turbine starts rotating, and this turbine is connected with a shaft with a generator. Okay, shaft means here with one rod with a generator, and generator also starts rotating. So this turbine rotates this generator, and generator generates electricity. Okay, so therefore electrical energy. So we can say that potential energy is converted into kinetic energy, and potential and kinetic energy combined, we know that is mechanical energy. So due to mechanical energy, the turbine, the blades are getting rotated, and as these blades are getting rotated, it is converting into electrical energy, and that electrical energy is further used into many other energies like heat energy. You see that iron press, heat energy, it can be used in calling bell, that sound energy. So likewise the energy is being converted in hydroelectric power plant. So law of conservation of energy means energy can neither be created nor be destroyed. It gets transferred from one form of energy to the another. Okay, so that the total energy remains same. Now here you see one question, conversion of energy while running a car. Now what are the different conversions while you are running a car? That means when you are driving a car, what are the energy conversion is taking place? Okay, so this has a long story. You see, first of all, if we say that how plants produce food, so the plants prepare their food in the presence of sun. So that means solar energy is converting into chemical energy stored in the food. Okay, now when this food is being utilized by plants and animals, when these animals eat this food, that means that chemical energy is stored in animals. Now when these plants and animals, when they die, they are buried under the earth surface. Now when they are buried under the earth surface after millions of years back, this converts into fossil fuels. Now these fossil fuels means here petroleum, diesel, kerosene, they run the automobile, and this automobile converts the chemical energy into heat energy. So the heat energy which makes the vehicle move. So you see how our car is getting moved. That means the fossil energy contains the chemical energy. This chemical energy, when they are utilized in the cars, it converts into heat energy, and this, because of this heat energy, our vehicle starts moving. So here we see potential and kinetic energy during a free fall. That means when an object is thrown up in the height, it has more potential energy, but when this potential energy, when that object falls down, again that potential energy gets converted to kinetic energy. So total energy remains constant. Okay, so you can see here one table, that is toaster. Electrical energy is converting into heat energy. So what does the toaster do? So conversion of energy takes place. Toaster converts electrical energy to heat energy. Blender converts electrical energy to mechanical energy. Hydroelectric dam converts gravitational potential energy to electrical energy. So likewise, this you have to remember and note down in your exercise book. So power is defined as work per unit time. That means power depends upon work, it depends upon time also. So how power is defined as? Power is defined as rate of doing work. That means in less time, if you are able to do more work, then your power is more. In a more time you are doing less work, then your power is less. Okay, so that means joule per second. Joule per second is also written as watt. Okay, WATT. So watt is the unit of power, or you can write in joule per second. Okay, both are correct. Okay, and you see the differences between energy and power. So this exercise or this chapter is over. Exercise questions will be your homework. Okay, so you are asked to find the answers by yourself, and you will be doing it by yourself. Okay, in the next class I will explain the numericals. So numerical questions also you can try by yourself. See the example questions and make sure you write each and every question answer in your exercise book. Okay, in my next video I will just discuss the answers, and so that time you will match with your answers. Okay, so answers which you have doubt, you leave it blank. Which you know the answers perfectly, it is given in the textbook, you note down in your exercise book. Thank you.